Hello, and welcome to the Edge Computing Workload Orchestration session here at SUSECON Digital 2021. Thank you very much for joining, and I hope you learned something and have fun. So, my name is Brian Gartner. I'm a Senior Technology Strategist here at SUSE, and I work on our Alliance team, and I get to work with all of our hardware, embedded, and software partners to make sure our cool portfolio of things works great on top of and with their things. And with that, I'm going to turn it over to my peer, Brian Fromm, for his introduction and the next section. Thank you.
Thank you, Brian. My name is Brian Fromm. I'm a Technical Alliance Manager here at SUSE. Here's what we'll be talking about today. So let's jump right in. Let's talk about where edge computing really evolved from. So if you think about the Internet of Things, a group of what we call makers were experimenting with smaller and smaller devices and really putting Linux on these devices and trying to put conventional programming capabilities on top of that so that it was easy to write applications for these devices to do things that would make sense to the makers, right? Maybe run their doorbell or garage door or something. So that's kind of the beginning of the Internet of Things. It's really the same thing for edge computing in the enterprise. What are we doing at the enterprise level at the edge? We're bringing devices and cameras and kiosks and point of sales devices and a plethora of other kinds of sensors and devices together into an application environment that bring a service to customers to connect the enterprise and the customer more closely and in a digital way. And that in and of itself is a challenge. And there are a number of challenges here, but one of them is just managing the application environment. So that's what we'll be talking about today, is how we deal with the application environment at the edge. And then one other key piece of information to talk about is no one company really brings an edge solution to an enterprise. It's really a set of providers, from hardware and conventional computing companies and hardware providers to conventional software companies to specific device manufacturers and code that goes with those devices to integrators that have a lot of knowledge about specialized software layers at these components. And all of that leads to, again, the edge applications, which are typically written by the enterprises themselves, because those are the actual services that bring together the customer and the enterprise. So let's talk about the edge and some kind of locations where edge computing happens. And on the left side, you see what we call the near edge. And on the right side, you see what we'll refer to as the far edge. And the near edge is really the conventional telco environment where telecommunications and media providers are building content networks and networking and 5G and things that we're familiar with. And the technologies in that space are typical to the telco environment. The far edge is really more of the devices that we've talked about already, that are smaller devices that interact with customers or interact with a service from the company in a specialized location. And then there's even what we'll refer to as the tiny edge, where miniaturization is making devices smaller and smaller that make for more and more devices that are maybe not a handheld size, but even just buried into some other technology or into some other real life scenario. So let's look quickly at the markets that go with those. On the left side, in the near edge, we have what you think of as a telecommunications market. And that, again, the providers are the typical providers that have been providing for years in that market. Those are network equipment providers and hardware and software providers, but they're specialized for telecommunications. And on the right, at the far edge, we have what are more vertical markets, right? Like industrial markets, manufacturing or oil and gas, or commercial markets like retail or hospital for healthcare, or public sector like governments. I think one example there that's very interesting is the smart city approach where cities like the city I live in are bringing technology, edge technology to bear in the town where sensors and components are driving all sorts of different pieces of city infrastructure and allowing the citizens of the city to interact with the environment in various ways. And the ecosystem there is very much like we're used to in an enterprise, right? Hardware and software providers, the same ones we deal with typically. Some new ones that specialize in specialized devices and cameras and specialized pieces that go at the edge. But the hardware and software infrastructure and then the system integrators, these are the conventional ones that we're used to in these particular markets. So with that, I'm going to pass it back to Brian to go into more depth on the challenges and then the technology that we bring to those challenges.
Thank you, Brian. And as you saw in those previous slides, you see it as a diverse distributed ecosystem for edge computing. And what I'm going to cover next is several categories of the challenges that you need to address and take into account as you're planning to do this, as you have done it and you're maintaining it, and doing the operational aspect of it as well. So let's go over some of the top challenges and know that there are more than these, but these are some of the most common and some of the bigger difficulties to deal with. So first off, let's talk about the category of extensibility. As you've noticed, this is truly a distributed computing mode. You have devices from any place across the world that you need to deal with, okay? And you have to empower that to run sometimes, well, you hope that you can do greenfield and new applications and stuff like that, but you still have some legacy technology wherever. And I always talk about this as an example of a lily pad. You need to move from where you're forward to the next lily pad to get you to where you want to be in the future. Next category is all around compliance and security. Again, because of that distributed nature of this, you have devices that you don't maintain. You can't lock in and do things and keep hands off and everything like that. And plus, the internet may be the way into these devices. So you have to get it to a known desired state and make sure that it stays there and observe potential breaches and deal with that. Also being able to do maintenance and security kinds of checks and keeping the number of vulnerabilities down and reducing the risk. Finally, the last aspect is governance. Again, across an organization, you need to think about how all of those people, both internal and the external ones, how they can access these devices in the way that they need to, for the reasons they need to, and only for the aspects that they really need to. Okay, so really, who can do what, where, and when, and how across that entire ecosystem. So those are the three top challenges. And as I go through the various layers below, I'll address each one of these from those categories. So let's start down the path and talk about how you deploy, manage, and orchestrate these workloads everywhere. Okay, let's start at the bottom of the stack for an operating system kind of perspective. If you're talking about a solution stack and just put it in the OS at the bottom level. Let's talk about an option that you have in the edge space. There is an offering from SUSE called SUSE Linux Enterprise Micro. And we'll look at the figure on the right-hand side. It is an operating system, and it gives you the ability to do any kind of workload, whether it's more traditional, like installing a package and just running it on the bare metal node, or it could be utilizing a hypervisor and creating a workload that's a virtual machine, or it could be a container image that's running on top of this operating system, or you'll see later there's a way to orchestrate lots of container workloads. But you have that extensibility that you can support any of those workload types. But of course, moving forward, most folks, especially in the edge space, are heading towards containerization. From a deployment standpoint, a lot of this can be automated. There's three things here listed here: Yomi, AutoYast, and Ignition. So of course you can manually do the install and walk through the wizard and answer the questions and the install is done. But you can capture those answers and just reinstall that over and over and over again in an automated unattended standpoint. And further, you can add things like the credentials for that given node to be a certain way, and or packages and or whatever you need to do, so that it can be redeployed over and over again, or its peers that show up, the other 10 devices that are just like it, can leverage that same thing too. Okay. So in the challenges space, if you talk about compliance and security, this operating system is very immutable. It's read only. So once you have it set up and running, it's very resistant and it's a low risk to have problems come in. And even further, you can tighten it down further with tools like SE Linux and the policies and everything to say, even if you're running this workload, all they can do is touch this file, this file, and this file, or read that file. Okay. And when you look at the certification aspect, because SLE Micro is based on the same kernel as SUSE Linux Enterprise, you get all the same hardware enablement. Plus, you also can leverage a lot of the other certifications that are in the security space, whether it's things like Common Criteria or FIPS or STIG or things like that. And that gives you the ability to have a very secured footprint. Okay. And then finally, from a governance standpoint, and I'm going to give you a real simple example here, included in this SLE Micro is a tool called Cockpit, which is a web user interface. And literally, I can manage the node, I can see the performance, I can do all that on a very one-to-one basis, which is an issue as you scale in the edge space. But just to get you started, this is a great way for you to interact with that device and do what you need to do until you move on to even a more orchestrated workload and orchestrated management sense. Okay, so let's talk about now if you had a bunch of those devices that were running something like SLE Micro, how do you scale that up and do management of all of those nodes? Okay, so you can see that there's a whole bunch of them on the right-hand side. Well, okay, 3, but imagine that each one of those is representative of an indication of 1,000. So when you have that distributed environment and you have all of those devices out there, what you want is a tool that helps you be that control plane, that management plane for the devices. And this is where something like SUSE Manager comes in. It gives you the ability to automate the deployment, kind of like the next step beyond what I mentioned for a single node from before with SLE Micro, that it basically can be as simple as when a device gets plugged in, and I knew that this MAC address was the network that it came from, here's what the role I want it to be. And so it updates the image, it installs any of the workloads on it. It could integrate with higher level control planes, which I'll cover in the next couple of slides. And it can also start to do the monitoring aspect and the configuration management to make sure that, X is always in place on this node and Y is in place on that node. And the status, the immutable status is always in place. And even if somebody tweaks it, it's going to revert back. Okay. So then in the challenge about the compliance or security, SUSE Manager has the ability to generate those CVE reports so that you know if there's an open security issue and have I addressed it already on this device. Okay. Furthermore, you may just want to be able to patch and upgrade or just do normal maintenance kinds of cycles of, the third Sunday of this month between 1 and 3 a.m., I want these set of nodes to be patched and updated regularly on a regular basis. Okay. With SUSE Manager, you can do that. You can schedule it and say that those nodes are in this maintenance cycle and they need to get this done. And you can stage the updates ahead of time and test it on an in core, in data center, somewhere environment to make sure that it's okay. And then you say, make that happen on the third Sunday. Finally, the last aspect is around the governance. And kind of like I've hinted at with this, you can label nodes and group nodes. You can say that, hey, this is a minimal edge computing device and it's in this group. So always treat it this way and always treat all of its peers the same way. So that could be as simple as I want this workload to be on that peer group all the time. Okay. And you do that with the labeling and whatnot, but you can also do it from the other aspect as well, the other end of the pipeline of what organization is managing those, what part of your organization, what department, whatever, or what can a specific user do. So you could say John Doe as a user can log into SUSE Manager and he can see all the devices and he can generate a report saying, oh, okay, this is the status of it. But he can't deploy workloads on it. He can't make changes. He can't modify them. He can't do whatever. Whereas Jane, who comes along, she's the one that can do more of that stuff. Okay, so it's a tiered approach, role-based access kinds of thing. That's what SUSE Manager gives you the ability is to scale up device management and node management to edge because of the sheer number of those devices out there. Okay, so let's move on now to the workload aspect of it, okay? And we mentioned that you could run any kind of workload on that operating system. But let's say that you are moving forward and you're either doing greenfield or you're already on the digital transformation and you've already picked containers are the right answer, okay? One of the things that really comes about is how do I orchestrate and manage those containers and whatnot? And of course, the de facto answer is Kubernetes because of all the features and it just does everything that you probably need and probably even want. And what's really cool about SUSE and the Rancher portfolio is that we have an offering called K3S, which is a very lightweight, easy to deploy Kubernetes distribution. And once it's installed on that node, now everybody that's running cloud native containerized microservices, they could care less about all those foundational layers that I just talked about below. They just want to know, they just know that, hey, Kubernetes API is there, that version is there, therefore I can write this manifest, this Helm chart, this operator, whatever, and I can deploy what I need to do. And so they're going to be smiling from ear to ear going, thank you. Now I can do an edge workload in a way that I'm very comfortable with without having to worry about how it happens to run. All I need to do is write that simple wrapper around it with the manifest, the Helm chart, the operator, whatever. And K3S gives you that ability to have that default Kubernetes API for all of your workloads. So now the extensibility thing is a done deal, right? If I had 1,000 edge nodes that are all running K3S, for the developer, that's like as simple as I can run K3S on my laptop. Yep, it all works fine. Push it into the registry and make it so. Launch it across all those nodes. Okay. So you have that ease of build, you have that, that portable instances that they can run anywhere and do whatever you need to do. And now you have that full-blown orchestration of where they land. So even like in a deployment stance of the deployment is actually 5 pods that make up this function. It's still one thing to just launch all those and make it happen. And at the compliance and security level challenge, K3S is CNCF certified, so done deal. It's very useful. It's very uniform, all that good stuff. And if you need to, and this is something that starts to come in effect really quickly when you start doing edge, because what are you doing? You're pulling in data from sensors, and I want to react to that and provide analytics or do whatever. So with a tool like Longhorn, which is local persistent storage, it creates a storage class for Kubernetes, persistent volume, and persistent volume claims that can go with any container you want. So now that developer just adds that into the manifest, the Helm chart, whatever, and it just utilizes that storage and does what it needs to do. And furthermore, at the governance level, once you're into that Kubernetes space, now you can leverage all the role-based access stuff. And I'm going to talk about that more on the next space. But again, it's who can do what and where. All right. And once we have those Kubernetes APIs offered by K3S and the Longhorn stuff of the persistent storage for stateful containers and things like that, we have the ability to do whatever we need to do, even at the edge, which is awesome. Okay, now let's scale that up again, right? We talked about K3S and Kubernetes, and that's how you orchestrate the workloads on a single node or a single small cluster of nodes. But if you go up the next layer, the tool called SUSE Rancher gives you the ability to do multi-cluster management. So now that ecosystem that's thousands of nodes across the globe and doing all this stuff in different ways, shapes, and form, we have a consistent cluster operations management interface where I can run and manage workloads and maintain the clusters. I can address platform services for each one of them and say, hey, in this environment, I need this version of Kubernetes, and I need it to have these services and these things turned on. With Rancher, you have that key to that kingdom across all of those castles and all of those edges across the globe. Okay. And from a compliance and security thing to address that challenge, you do have that centralized place where you can create and enforce policies, whether that's at the container level, the network level, or even beyond. You can do centralized auditing. So at that layer of Kubernetes and above, I can make sure that everything is configured the way I want and those policies exist and they're in the state that they're supposed to be. Okay. At the governance level, then even further, now let's say that we have an organization and or one or more where there is a single sign-on kind of capability. So it could be LDAP or Active Directory or whatever the authentication tool that you want. Now anybody that logs in that way, you've allowed them into Rancher. And again, like I mentioned before, with that role-based access call, role-based access control, then you can say that when this user logs in, they can see all of the clusters in North America and they can just see what's running and everything. And this person, when they log in, they can see all of them in Europe, and they are responsible to making sure all the policies, the security policies and everything are in place. And auditing is happening to make sure that they're staying that way. And then this third person who could be in Asia Pacific that's running edge appliances for telco or retail, they're the ones that can make sure that that workload is running and is updated and is performing as expected. Okay. And again, you have that single sign-on ability, but yet I can define the role for that person and they can do whatever they need to do wherever they need to do it. Okay. So that's the forte of SUSE Rancher. That gives you that umbrella, that centralized place where you have a user interface, a command line interface, or just poking at APIs if you want programmatically to do this, to control all this stuff everywhere, or whatever gated things that I want to be able to, that I'm allowed to control and do whatever I need to do. Okay, and while on the last one, I just talked about what SUSE Rancher does to address those three kinds of challenges for edge computing. It is far bigger than that. It has a superset of things that it can deal with, right? You can do deployment of clusters. You can do monitoring. You can do in the run and manage mode. I can do everything I need to do. And if I need to spin up a test cluster in a cloud service provider that's just like the edge cluster that I'm either having issue with or I'm getting ready to deploy, I can spin that up and let the developers and the operators have access to it, make sure they're happy with it, so that when those devices get shipped to the edge and they get deployed that same way, everybody is thumbs up and we can do that. Okay. Likewise, in that authentication space, I mentioned a couple things, but there's lots of other plugins. And both in the build and run space and even the governance space, there's all of these other things that you can do beyond just addressing those three challenges. So it's like you get this huge, bountiful present and you can do all this stuff with it, but you need to address the challenges up front. You can check those and done, and then you can move forward even faster. So that's what SUSE Rancher does. Okay, with that in place, let's talk about summary and some of the takeaways that you can do. And to wrap up, here's the slide that kind of throws it all together. And again, the goal was to address those three top challenges for edge computing: the extensibility, the compliance, security. And with that portfolio of products, SLE Micro, K3S, Longhorn, SUSE Manager, Rancher, you have the ability to do that. So please, if you need help, let us know. We're really glad to help you. If you want to go down this path, all of this stuff is out there and documented, and you can start playing with this, and literally you can deploy it all on your laptop and go, oh, that works really well, and then scale it out to multi-node clusters and keep going and keep going. And then it's more about just what workloads do I need where and running to make my business more successful once this infrastructure is in place. And with that, again, thank you. Feel free to reach out. There's some links here and whatnot. And also look on the schedule for other things about any of those technologies, whether it's SLE Micro or K3S or SUSE Manager or SUSE Rancher. There probably are some more detailed things, and those presentations may help flesh out things even farther for you. So thanks again.